to welcome in the next guest. Okay, so next we have we are going with Dr. Pshtiwan Shakor is joining us from Iraq. I won't give too much of an intro because we are running quite behind, so I'll just let him get into what he has to present for us today. We'll bring you in now. Hello, thank you for joining us.
Hey, Peter, how you doing?
Good, thank you. I'm looking forward to hearing your
your
presentation. So thank you.
Yeah, for sure. Thanks everyone. Thanks for Peter for this opportunity, and thanks for Farid as well. So, because reign of time, I'm just going through my presentation. Okay, so basically this presentation was a published paper, and this presentation is done by me and Farid as well. I was really saying like, thanks Farid for this opportunity we done together, because we got a kind of help from a manufacturer and from Farid as well to give us some idea to our students from University of Technology Sydney, Farida Vinod. So basically we are talking about kind of AI, like artificial intelligence, how to be used in a steel components in a manufacturing structures. Like in a manufacturers, you need to do some inspection. For those inspection, you need a kind of people to inspect the bolts and holes whether properly attached to the steel structures. So basically we have been using kind of ESP cameras, ESP32 cameras to detect those faults and errors in a steel manufacturer. So this technology is kind of new for construction, because this is being used before for different kind of AI in computer analysis. So we have been trying to use very cheap camera, like a $9 camera, and we have been using some kind of steel structures to complete our work, because one of the a manufacturer in Australia, they have this issue, and we would like to solve that issue. Actually, we got a very good results with a very limited amount of money and help as well. So basically we do this one to detect the quality insurance in the old buildings, whether every single piece of steels whether will be welded together well or bolted well together, because it's need a kind of connection between each steel parts. So here I would like to say from the literature, we got kind of earlier work from Park in 2015. He did some kind of work, but he really not mentioned these kind of bolts can be detected properly or not. But we would like it to introduce kind of this technology and develop it further to detect all types of the errors in the steel manufacture, for example, detecting the bolt and detecting the holes as well. So if we have any issues, we can figure out where is the problem. So we have been using kind of like a materials and technology here is like a methodology. We have been using canny edge detection, which is a kind of C++ programming language to detect all the colors and bolts together. And we have been using kind of algorithm which called RCNN algorithm, or faster RCNN algorithm, which is very helpful to detect those problems here. And combining both technologies, it gives us the problems where is located as well. For example, if steel parts doesn't have a bolt and nuts, so they detect it straight away. So basically the deep learning of the bolt detection, it's kind of process. You need to get this process until you get the results. So this process, as you see in the image, so how you take a photos of the stuff and how you analyze it, it's all like a kind of feedback from the algorithm. So you put the image and object detection, and using the selected area that you want, because you may have a lot of stuff in the image and a lot of stuff in a background, but you may need to focus only on those things that you want to detect. So here what you did, we have a kind of like a equation and to calculate those stuff, which is called m multiplied by n multiplied by d plus 1 in a bracket multiply all by k, which is meaning the shape width of the filter multiplied by shade height of the filter multiplied by number of the filters in a previous layer plus 1, all of them multiplied by numbers of the filter. If you see in those images, it can be detected by region. So, and it tells you later on whether this is a human or something else. So this is how the RCNN is work, or we can say like algorithm works. And another thing we should be considering doing this kind of analysis, we need to know how many images we have. For example, those images, how can be used as well. For example, we have sometimes like 18,000 images. So some images you should put on a side for a training, which is called a training set. And this amount of training set, it should be higher than the other sets, like a test set. So if you can see here, I showed we have like a validation data and validation data set, test data set, and training data set. So in a training data set, you need a lot of amount of images, for example, 80%, sometimes 70%, sometimes 60%. And for validation data, you need less, and test data as well, you need less than that. So for test data and validation, most of the time should be equal. So we have been using like a kind of experiment on the bolts. We have made it this custom made that like a steel and the bolts and nuts. I'm really thanks Thierry that she did all the stuffs by herself. So, and we just guide here. So we basically found it out how we can detect these bolts without the holes, because all the stuff is very important for us, just detecting sometimes whether we have a bolt or we don't have. Because if we don't have a bolt, we may face issues like a shear stress during the installation of the steel frames. So basically, she used two kind of cameras. She used ESP32, which is very low pixels in a camera. I think it's about 3 megapixel. The other one is they use the iPhone one. It's about 12 megapixel. So the cameras, if you have a lower version or lower quality, so you have a lower result as well. So this is just for comparison and check it out how it works. So basically in a Canny Edge, you can change your photos or your images into Gaussian filter, like a different kind of filters is like a grayscale filters can be said. So, and we have been using that faster RCNN to detect all the stuff. If you can see here, faster RCNN in here, so it have like a kind of region proportion area or network. So you can differentiate it from RCNN network by itself. So, and the other things we have been using, use it like a kind of SSV. So it's kind of color stuff that you need for hue and saturation value color picker program. So, and from that point, we can detect kind of the bolts and nuts that we have. So when we have been like figured out in a different color, you can see different kind of purpose areas that you need. From here, you can see the differentiation between the like cameras that we have been used. I think that, yeah, the other one, the cameras that we've been using in a SP is just 2 megapixel, which is the one is the figure, the photos in the bottom. The photos in the above is just the iPhone camera, which is about 12 megapixel. You can see the qualities of those two images. And we have been like detected those spots that we need, whether the frame is connected together by bolts, as tells us in a like a green color, and the areas we have been holes is just telling us in a red color. So until we can differentiate it. So for those figures, we have been using like a different kind of iteration. This iteration, if you have a more high iteration, you are getting like a higher value in a precision, which is called mean average precision as well. So we've got like for this ASP, we've got ESP32 cameras, we've got about 82% MAP, or you can say mean average precision. But in a iPhone cameras, we got very good results, and we have been using different kind of algorithm with help of the TensorFlow and RoboFlow. We have got almost about 95%. So in engineering perspective, the 83% is very low. So we need to increase that until we reach about 90 or above 90%. So we got about 95% for that purpose if we are using like a different kind of algorithm and you have more iteration. At the end, I would like to say this kind of bolt detection, so it was very successful. Even we have put different type of materials beside it, it will detect the spots that you need, and it figure out where is the bolts and the holes located. As you can see here, in green color shows us like the holes, and like a blue colors tells you where is the bolts located. So until we figure out those places that are having a holes, until we go in and check it out again and use the bolt to attach all the materials together. At the end and a conclusion of this like a study, where we have been using the canny edge detection, very open, like a positive results we got. And at the end as well, the ESP camera is having the low clarity compared to the iPhone one. And these results can be more accurate if we have been using like a TensorFlow and RoboFlow to training more of the data. So if you have even more images, you get a very higher results. Thank you so much for your times. And if you have any question, you can just straight away send me the email via this email address. I'll leave the times for the other presenters to present their presentation. Thank you so much.
So wonderful. Thank you so much, Pshtiwan.